So in this video lecture, we'll be solving this map, and we need to draw a cross section of this map along the XY, which is specified for this. Let us just see the important features. So these are the contour lines. As you know, we have solved 3 maps before this. This is the last one in this maps series. So we have these contour lines. We have the bedding planes, which are named as A, B, C, D, E. And we have the bedding junctions, which are shown in this as a dark line, and along with that we have something special in this map, which is shown here, FF dash. FF dash is nothing but it is fault. We have already studied in structural geology. If you remember, we have if you have forgot what is a fault, you can always check on the geology playlist on this channel. You'll understand what is a fault, right? So this map has a fault, and we are going to draw a cross section. Let us see what is given. The given geological map shows 2 sets of repeated beds A to E on the northern part of the map and A to F on the southern part. 2 sets are separated by the line FF dash that represents the trace of a fault plane on the Earth's surface. The map scale is 1:1000 and the contour interval CI is 10 meters. The step 1 remains the same, that is, we need to mark those contour points where the bedding junction and the contour lines they intersect twice to the same bedding junction. And then step 2 is also combined in this, that we are also going to determine the missing strike lines. So let us see what exactly we need to do. This is the map, but now before actually going into the marking of the points, let me explain you something about the fault. So this, as you can see, this is a fault interface basically. So what it does is, the fault plane, this plane as you can see where the faulting has taken place, that would be called as a fault plane. And this fault plane, it divides the entire rock into 2 parts, the one on the left side and the other one on the right side, right? Now interesting thing is that, let us say that I have a rock like this. Okay, I have a rock something like this. Let me just draw it a little bit more steeper. Okay, and let us see that a faulting takes place this way. Okay, so what will happen is, this will be one part, right? This will be one part of the rock, and the other part will be this one. Let us say now the faulting has taken place and the rock has come down this way. Okay, the interesting part here to note is that the inclination of the rock on this part is the same as the inclination of the rock on this part, right? So this inclination, this is what I am referring to, this inclination is not going to change because of faulting. That is what you need to understand, right? So if that inclination is not changing, it directly says that the strike lines are going to be at same distance in both the parts. So here in this map, if FF dash is the fault line, so this entire thing is one part, this is the other part, right? But the thing is that the dipping of both the parts which are separated by the fault line, they are going to remain the same, and hence the strike lines spacing is going to remain the same for both the parts. But I am going to show a different color of strike line for this part and a different color strike line for this part. Okay, now in this map, one more thing which is special is that along with the strike lines of the rocks that we draw generally, the strike lines basically what they indicate is how is the dipping of that rock is there, means what is the general inclination of that rock. But along with the rocks here, there is one more thing which is inclined, and that is the fault plane, right? The fault plane has its own inclination. It is independent of the rock inclination. Okay, so you can see that this angle is definitely not equal to this angle. So the fault plane has its own individual inclination, and hence we are also going to draw strike lines separately for this fault plane. Okay, so there are three things that we'll be doing in this map. We'll be drawing strike line for this part, for the upper part. We'll be drawing strike lines for the lower part, and we'll also be drawing strike lines for the fault line. Okay, so let us start by marking those points. First, I am taking this AB junction. In the AB junction, as you can see, this contour line of 90, it is cutting once here, and the second one it is cutting here, right? So two times it is cutting the same bedding junction. This is what we are looking basically, and through these 2 points I can draw a line. This is one strike line that we have drawn. Okay, for the same bedding junction AB, let us say if we have one more, so this 80 is there, it is cutting once here and once here, so we can draw a strike line through that as well. By these two strike lines, I now know what is the distance between them. Okay, and by the property of the strike lines is such that the other strike lines will also be at the same distance for the same inclination. Like, since this upper part is going to have almost the same inclination, hence the strike lines are also going to be equidistant to each other, right? Then let us see if there is anything else on this AB junction. So we do have this 100 contour which is there, and one point is here, but other point is imaginary. It is somewhere here. It's not imaginary visual, it's not shown in this map, so you have to just extend these lines and you'll get that point. But I'll just exclude this 100. Means I don't think it is absolutely necessary, because I guess the strike line is anyways not going to pass through this, it's not going to come inside this XY, as our final aim is basically to draw a cross section of this map along this XY line, right? And if this strike line is not coming inside the map here, then there is no purpose in drawing that line basically. Okay, so that is the reason I'm not drawing it. Let us move to the next bedding junction. We have this bedding junction BC, and on this bedding junction BC we have this 100 here. First it is cutting the BC here and then here. Then we have this 90, right? Then we have this 80. So we draw a strike line, and these would be equidistant. After that, for this BC we have the 70 which is there, so I draw a strike line through that. Now there is no more contour lines which are cutting twice for this BC. Let us move to the next bedding junction, which is CD. So on the CD we have let us say this 80 is there, right? 80 we can have. We can also have this actually 90, which is somewhere which actually would be, it would intersect here actually on this strike line, and this would be somewhere here like this. And that is left upon you whether you want to draw that or not. 70 is there, so we'll draw a strike line through that. Then 60 is there, here we'll draw a strike line. And if you see, then I am not taking these strike lines across throughout, because this F dash is a fault and it has divided the entire rock mass into upper rock and this lower rock. So I'm not taking these strike lines into the lower rock, as I already told you that I'll be showing them in a different color, just so that we can distinguish properly. So these red color strike lines are for the upper rock, and for lower rock I'll be using some different color. Now the 60 which is there, the other side of the 60 is not seen due to this fault. It is because if this rock was completely fine, that is, if no faulting would have taken place, then the 60 would have definitely come somewhere, if we just extend it this way, then it would have come somewhere here. But now, right now, it is not seen because of the faulting process. After this, let us move to the lower rock now, the lower rock side, and we have again this AB junction, and on this AB junction we have the 50 contour, I'll just pass a line through it, and now I'm using blue color strike lines. But the interesting property here, as I already told you, is that these strike lines are going to be at same distance. The reason being that the inclination of the rock is not changing because of the fault, right? Hence the strike lines are going to be at the same distance. After 50 we have this 40 which is there. I'll pass a strike line. Then coming to junction BC, we have these two 40s here, and we also have 30. Then I guess that's it for them. Then if I go to this AB junction again, we have this 60 which we have here, and the other side of 60 is not visible. It is because of the faulting process, but it would have been somewhere if I draw a strike line with the same distance parallel to them, then it would be something like this. Again, if I just extend this, and if I extend the 70, it would meet here, and the other side is not visible because of the faulting process. So I can draw a strike line there as well. Okay, now what we need to do is that we need to mark the missing strike points basically. So what we need to see here is these strike lines that we have drawn. You can see that there are certain points which are exactly what we want. That is, they are the intersection of the bedding junction, they are the intersection of your contour line, and they are the intersection of the strike line as well. So these are those points which are definitely something that we need in the map, right? That is what we are always finding basically, all these points. So but because of the faulting process, this, let us say that the point that I had drawn, this point, now this point is lying on the BC junction, right? So this BC junction, if you trace it somewhere, if this is going like this, you know, so, and if I just extend this strike line, then you will get this 60. See, this 60 would come and intersect here, this 60 contour line, right? So these are the points that we need to mark now. Again, if you see here, this 50 contour line, if we extend it, it is meeting here at this point, and on the other side this 50 is meeting at this point, but this point was not marked, right? So such are the points that we need to mark now. So we have this point first, then we have this point again, the bedding junction, contour and strike line all are intersecting. Then we have this point, here we have this point we have. See, there can be a little bit error, that would be because of the drawing, but ideally if the spacing is very less between the intersection contour lines and the strike lines, then you can consider it to be a point there. Okay, as the case was here, you can see that it's not exactly coinciding. That is because of some error in the drawing, but the point would be there. Then coming to the next strike line, we have this point is there, this point is there, then this point won't be there because there is no bedding junction there. Here we have a point, correct? Coming to the next strike line, we have this point here, here we have a point, here we have a point, right? And can we draw one more strike line? Yes, you can see that this 60 contour, this bedding junction is actually, and if you draw a strike line parallel to these at this equidistant, you can see that you can draw one more strike line through it. And I will leave upon the students that if you want to find more strike lines or more strike points, for example, even in the upper part of the rock, if you see, then this 90, if we just extend it, it will meet here. Then this 90, if we extend it, it will meet here. So these can also be formed as the points, right? And the CD junction, if you extend, it is going to meet somewhere there, yeah, like this. So this I will leave upon the students to mark more points if they want. Otherwise This much is enough for drawing the map. Now, as I had already told you that along with these two sets of strike lines, we will also have a third set of strike line which will be drawing for the fault plane. So this is our fault plane FF dash, and here also again what we essentially want to see is that the contour lines which are intersecting or which are passing the same fault line two times. So here we have this 50 contour line which is passing the fault line twice. We'll draw a strike line through it, and this would be in the green color. Then this 60 which is there, it is passing here, again another strike line. Then we have this 70 on both the sides. Then do we have anything else? 80 we have. Yes, see this 80 is there and it goes all the way like this, and here again 80 is there, right? So we'll pass a strike line. So you can see that the spacing of these strike lines are definitely different, which indicates that the inclination of the fault is different from the inclination of the rocks. Okay. After this we have to name our strike lines. So first name here would be AB 90 and BC 100. Then the second name would be AB 80, BC 90. Third name would be BC 80, CD 90. As I told you that there is this point here which would come. Then we have BC 70 and CD 80. Then this strike line would be CD 70 and DE 80. This DE 80 would be, if we just extend this DE beyond and this 80 somewhere, it will intersect on the same strike line, right? So we can name that as DE 80. This is also a missing strike line. That point you have to draw. Otherwise you can just write the name of the strike line. Coming to the next one, we have CD 60 and DE 70. The next one is DE 60. That's it, right? Moving to the lower rocks, we have AB 70, we have AB 60. This one would be AB 50. Then it is BC 60, CD 70 and DE 80, right? So this DE 80 is there here. This point we had not marked, but that point is also there. It is a intersection of this contour line, bedding junction and the strike line. Then coming to the next one, we have AB 40, BC 50, CD 60, DE 70. The next one is BC 40, CD 50, DE 60, EF 80. Next is BC 30, CD 40, DE 50, EF 70, and the last one is EF 60. So these are all the names of the strike lines. Then we also need to name the strike lines through the faults. So this would be just F80. That is, since there is only one point, one contour line, and along that we have drawn the strike line, so that would be F80, F70, F60, F50, right? Now we need to draw the direction of the true dip. You need to understand that there will be only two dips here, okay? The two dips are, first is of the rocks. Since the inclination of the rocks on the upper side and the lower side are the same, so we can only represent them by one dip, one dipping arrow. And for the faults it will be another dipping arrow, right? And this arrow will be always perpendicular to your strike lines. That is what the definition of the true dip. Amount of true dip and direction of strike line. So the direction of the strike line is basically, you will have to measure the angle that these strike lines are making. So you can extend this like this, and you can just measure this angle. This angle would be something, yeah, you can either write it as a whole circle bearing or a quadrantal bearing. Same is for this fault line as well. So for the fault line also, you can either extend this north down and you can just measure this angle. So that angle would be your whole circle bearing angle, or in quadrantal it will be north, theta, east. Then to find the true dip amount, you will have to measure the horizontal distance between the strike lines. That would be in centimeters. Okay. The scale of the map is 1:1000, and now the formula and the contour interval is 10 meters, which is actually 1000 centimeters. This is a formula for the true dip amount, and this formula I had explained in my first video, how to find the true dip of a particular strata. Same you will be doing for the fault also. You will also be measuring the distance between the fault strike lines, and you will be using this formula itself to measure the true dip of the fault plane. Now comes the main part, that is drawing the map. So I'll be superimposing a strip of paper, aligning it with that XY line, and then we'll start marking. First we should mark X and Y, then we should mark all the strike lines and write their names. Here I am showing with their colors so that you will understand which strike lines are for which rocks. Then we need to mark the bedding junctions AB, BC, CD, DE. This would be BC again, CD, DE, EF. Then we need to mark the contour lines 80, 70, 60, 60 again, 70. Any other contour line intersecting this strip of paper? I guess no. So that's it, and now we can plot our strike lines. So this strip of paper, you will have to keep it horizontally, and then we need to draw the cross section. So this is that strip of paper. I have kept it horizontally. Vertically, you need to draw two lines from X and Y, and the scale that you choose should be equal to your contour interval. So like here the contour interval is of 10. So this would be 10, 20, 30, 40, that way. Okay. The first thing that we do is you should always draw vertical lines from the strike lines, because on those lines only we'll be marking the essential points. These are the vertical lines of these strike lines, and for the fault strike lines I am showing a different color, that is green color. So you can start from whichever strike line you want. I'll be starting from the fault. So F80 on this vertical line, 80 is here. I'll mark this point, then 80, 70, 60, 50. Okay. If I pass a straight line through it, this is my fault plane, or this is my fault line. So I have marked my fault line first itself. Okay. Second is this EF, E7, EF60, EF70, EF80. So 60, 70 and 80. You can draw a line through it. This would be your EF bedding junction. Then we can say DE, DE50, DE60, DE70. You can draw a line through it, and see, the reason that I drew this fault line first is that so that we can limit these bedding junctions till the fault line only. It should not cross the fault line, because that is not the case, right? The fault line is dividing the rock into two parts. Then we have the CD, CD40, CD50, CD60. We draw a line. Then we have BC30, BC40 and BC50. We draw a line through it. Then we have AB40, AB50, AB60 and AB70. We draw a line through it. Now again you see that this AB would be on this side, because those strike lines were drawn by the blue color. See, this is the reason that we should always mark our strike lines with different colors so that we do not get confused. Even though these points are crossing this fault line, but we know that this AB junction is on the other side of the fault line. That is on this side of the fault line, not on the left side. Then we come to this AB here. It is AB80 and AB90 and AB80. I draw a strike line. I draw a line through it. That would be your bedding junction AB. We have BC100, BC90, BC80. Then we have CD90, CD80, CD70, CD60. Okay. Then we have DE80, DE70, DE60. We draw a line through it. So now we have drawn all the bedding junction lines. The next is that we need to plot the limit of the bedding junctions. Okay, what do we mean by the limit of the bedding junction is that this AB, this bedding junction AB which is there, that will go and it will rest on this line AB. Okay, this is the limit of this bedding junction. BC will go and rest on BC, CD here, DE here. Now this BC would go and rest on the rock on the other side of the fault line here, right? CD, this one here, DE and EF finally. The next, we should plot the contour lines. So 80 will just go and meet this 80 point, 70 would come here, 60 would come here, then we directly have here 70, right? So now the points that we need to connect are these points in yellow, in orange and blue that you can see. These are the points that we need to connect, and this will give you the boundary or the top surface of your cross section, and everything that is above that top surface we need to erase. Okay, so this is how the cross section of the map is looking. You can see that this side of the rock and this side of the rock, they are having the same inclination. The fault line is having a different inclination. So let us just show it properly. So basically what we do is that this entire thing is A, then this B and B, this becomes the B bedding plane, this C and C, it becomes the C bedding plane, this is the D, this is E, then this is A, B, C, D, E, F, this way. So this is your final plot, and you can see how the displacement has taken place because of the faulting process. So that's it for this lecture. In the next lecture we'll be solving some dip and strike numericals by the geometrical method. Okay, till then, take care. Thank you.